Marco Mancini from the Euro-Mediterranean Center for Climate Change Foundation, and he's going to talk about provisioning flexible and highly available iRODS-based data services at the foundation.
Okay, good afternoon. Okay, my name is Marco Mancini. I work at, as a scientist at Euro-Mediterranean Center on Climate Change. I work at the scientific, Advanced Scientific Computing Division. So we work especially on high-performance computing optimization, modeling, and data analytics and data management. So we try to provide tools, environment for the other divisions. The CMCC has 8 divisions, research division. So its focus mainly is on climate change, but is a multidisciplinary institution. It's a consortium of different public institutions in Italy, from Institute of National Geophysics and Volcanology to University of Salento, Politecnico of Milan, University of Sassari, Viterbo, and so on. So today we'll speak about a platform that we are trying to develop in order to provide iRODS-based data services at CMCC. So we'll speak about what are the motivation, the objectives. We'll start from an application that we try to implement, starting from an iRODS-based iRODS deployment. And then we will look at how we, as another presentation this morning, talk about solar. And okay, in the future we will look at Query Arrow and the Query Engine version 2 for metadata. But so in the last year we used solar for search and discovery. And then I will talk about the architecture of this environment that we are trying to develop at CMCC. And we are focusing especially on flexible and also available data services. So CMCC, as I said, is a multidisciplinary consortium mainly related to climate change, but they produce data on climate, ocean, hydrology, agriculture, socioeconomic, forest, ecosystem, and so on, climate indicators, risk assessment. So the fields are pretty heterogeneous, so we produce data that are related to different fields, but they are related to climate change. And for example, impact of climate on socioeconomic. So they evaluate, for example, the GDP and related to some climate change scenarios. And also some data can be critical and can be accessed in different ways. I'll give an example. For example, if I have a model for the ocean that produce data for a particular zone like the Mediterranean Sea, if I am a researcher on doing some coupling models, usually access data by subsetting, giving a bounding box, because I work maybe for areas. If I do some research on socioeconomic, I don't access spatial data by using bounding box, but I use country, I use region, I use NATS2 region, for example. So also they access in different ways data. And regarding the data format, mainly we produce NetCDF files. NetCDF is a self-describing format for files. So NetCDF has an header where it contains metadata, but it contains information about also how the data are on the file system usually. That data is a binary format. This is a self-describing format, and also is machine dependent. You have software libraries for opening, reading, writing, and accessing, subsetting the data. And, but we produce also CSV, or we access, for example, GRIB format files that are used, for example, for atmosphere by ECNWF, the European Center for Medium Weather Forecasting. So we can have different schemas, also data policies, and usually if we want to deploy some operational services, we can have different software components that we would like to have in the data services in order to provide in operational services, for example, for external data access. So here, for example, are two examples of operational service, data services that we have at CMCC. One is more than one are related to the Copernicus European framework that that CMCC is a data provider for the marine environmental monitoring services, in particular for the Mediterranean and the Black Sea. So they produce forecasting, analysis, and reanalysis data, and also for the Copernicus Climate Service. And then CMCC is a node in the Earth System Grid Federation for the SMIP5 for the Intergovernmental Panel on Climate Change. So, and these are, for example, services that we have deployed at CMCC. Some are operational, and daily operational means that every day we produce data for the service, like forecasting, daily forecasting analysis, and so on. So the point is how to provide users with, because at the moment the situation that we have is researchers just use, we have a supercomputing center, so we have HPC facilities, so HPC file system, a GPFS, a supercomputer, and then we have an archive based on tape library. And so they are used to file system. They are not, we don't have any, at the moment, we don't have any data management system that like iRODS in our supercomputing center. So, but last year, when I joined the supercomputing center for 1 year, I focused especially on the data management, the issues that we have at CMCC at the moment. And what we would like to do is to provide a unique global namespace as iRODS provides. So a researcher knows where knows about their file, their scientific data sets, but they don't have to know where the file is. It's just can communicate what kind of policies he wants to have, for example, for the file. And another point is that usually data that comes from model simulation, they are not shared like that, because, for example, at CMCC we use the NEMO ocean model that is used in Europe, and it has a format, the netCDF file that it produces. But in order to share the data, there are some conventions like the climate forecast compliant convention. So we need to do post-processing in order to get from the NEMO format to the CF compliant format. So we have some post-processing after the model output. So for example, we have to add some attributes. For example, for SMIP5, there are rules for a particular schema, so you have to add attributes. And netCDF you can add in the header like key value pairs, so they are called the global attributes, and you can add, delete, and so on. And so you can have, for example, also file naming rules in order to have an idea what file is contained. And so another point was to develop also a data portal for CMCC products in order to improve the collaboration internally, but also to publish some dataset external. So we have started with iRODS, and we decided to implement a prototype, proof of concept, let's say, for how to deal with SMIP5 files. So these are, we considered the node, the storage node that we have at CMCC. It's about 170,000 files and 100 terabytes. And so we have put iRODS, let's say, on top of it in the sense that we ingested the files with the ireg command, and then we used the netCDF microservices to generate the triplet for, by ingesting by indexing, the netCDF header. So the global attributes in the netCDF header, plus what's they call the variables, means the data sets that are in the NetCDF, for example, temperature, salinity, and so on, okay? So just the name of the variable. So the point was how to deal with a search and discovery for the data portal, and also in the earth science community and in our community, climate change. For data access, we use Threads data server because Threads data server is bulk transfer mode, remote access. You can subset remotely. So, for example, if I have a production of data about the Mediterranean, but I am interested just in the Ionian Sea, I can subset remotely. So I can download only the part of the data that I'm interested in, so I don't have to download the file then subset locally. So with the Threads server, I can do remotely, and then I just download the part that I need. So Threads data servers are used in our community, and we cannot substitute with something else. So the point is how to integrate this. So what we did is to use iRODS Fuse and the iRODS REST API for research discovery. So I mean, just querying the iRODS by, we did an abstraction. I mean, we created an abstraction like dataset and files, and then we used the iRODS REST API to query the metadata that we have ingested with the NetCDF microservices. And on top of it, we have built a proof of concept of data portal. And this didn't work because we had a performance issue with the metadata engine, and also there is a limitation on the queries that we can do because, for example, spatial and temporal queries are needed. So we couldn't express this kind of queries, and also faceting, grouping, clustering that are typical that if you want to know, for example, what kind of variables, and if I want to group what kind of files contain that variables for a particular zone, we cannot express this kind of queries. iRODS Fuse, unfortunately, I've read the paper about NASA Climate Center that they did this kind of virtual climate data server, I think 5 years ago. And they used iRODS Fuse with Threads, but we have found very performance issue, and also there is a problem with the caching. If I have an operational service that produces data every time, and we have an interval time that the data will not be available to be shared because iRODS Fuse cache data. The other point that we looked into it was, okay, we did only with this kind of experiment with IPCC SMIP 5, but we have other services. We cannot rely on one iRODS zone because it's difficult to handle with the unique metadata DB, and also we can have possible side effects for ingestion rule, and we have also need to modify files that are modified by an admin. So what we have tried to do is, okay, we substitute the metadata engine with the Solr for indexing. We tried to integrate differently iRODS with Threads, and the idea was to use multiple iRODS data zone, one for each data service. And then for this reason, we decided to look how we can deploy a data service, so an iRODS zone, in a way that is flexible, high available, and is pretty easy to deploy. So let's look first in how we can integrate iRODS with Threads. So we have looked at the Parrot virtual system, a virtual file system. Okay, we tried to start a Threads server inside Parrot. So it was, sometimes it was good, but what I found is it's pretty unstable. It didn't work. I don't know, sometimes it just was, it was freezing. But it was pretty nice as a performance, but we have tried also NFS RODS, but I tried to install also, but we had always segmentation fault. I don't know if there is someone from NFS RODS. And okay, the other two ways, that one is that Threads server, okay, can talk to a POSIX compliant. And iRODS needs always a resource that is related to a file system. So even if I have a resource, for example, for S3, I have a cache that has that is related to a Unix file system. So one way could be I can mount the file system for the thread server. Just the thread server can talk to the file system. But if I use a composable resource, I have an issue for the cache because I don't know if the file is in the archive. So somehow I need the backend that initiates the transfer from the archive to the cache. The other thing is that I have very different composable resources. I need a backend in front of the thread server that knows where the physical path is, which resources belong, and then can communicate, for example, to a data portal. And the last is what we have done, the first one. We have implemented the dataset source plugin and based on the jargon library. And we have looked at, there is a threads of 7 years ago, but I don't know if you have continued on this stuff because I'm asking then to the iRODS people, but I looked, there is a thread about threads integration, and we have started to look at this random access file class, and we are trying to implement with iRODS, with the jargon library. What we have done at the moment in order to test was this dataset source plugin. Oh, sorry. Oh, it's okay. Sorry. So the dataset source plugin, you can implement just an interface that is the thread servlet dataset source, just two methods. One is mine. You have to tell if that file must be dealt by this plugin or if not, because Threads data server implements different services like OpenDAP, NSubsetting, NCML for NetCDF markup language, or WebMap service. Implements a lot of services for NetCDF. So we can implement the isMine method, and then we can, if we implement a NetCDF, get NetCDF file. And so in order to implement this, we need a cache where we get the file from iRODS, put in the cache, and then the get NetCDF file, open the file in the cache of the Threads server. Then the Threads data server just deal with the file in the cache. So it can do whatever service. This works for the subsetting, but for some other doesn't work if I pass username and password via the basic authentication HTTP, because sometimes the Threads does more than one call to this class, so it lost the authorization. So, but we can also, what we have done is to put just for one user some variables, and then we can use this method also for some other services. For Solar, what we have done is to just use some rules for that are triggered by when I put a file or rename a file or a delete. And also about this, we use a Ruby script, but I know that there are some microservices. For example, a microservice for XML, and a microservices, for example, for doing a post, but we had issues with this. One of the issues was that if the post was pretty big, the plugin for the microservice for CURL had an error. I don't know if this is related to the field that is really more than some maximum characters that can deal with. So what we have done in this case, in Solar we put the Solar document ID is equal to the iRODS data object ID. Then we have a single value field for the iRODS data object paths and name. And then we have another single value field for each global attributes in the NetCDF header. And then a multi-value field for variable names, because an HCDF file can contain different data sets, can contain temperature, salinity, and so on. So it can have, for a variable, a multi-value field. And also spatial and time coverage fields. And this is related to the... Okay, regarding instead of the deployment of data services, so the idea is to have a backend that is cloud-based, and we use containerization technology, so mainly Docker images for components. So each data service has different, it can have different components, for example, iRODS, Solar, threads, but also some custom gateway and, for example, FTP or Science Gateway and so on. So the idea is to have a catalog of components and then to build this and deploy as Docker containers. Then we have been designing also a data service information access layer because we have a lot of data services. So the data portal can be built as an apps layer. So we have a data portal or whatever, another app that can use the information that comes from any data service. So I will describe quickly the backend architecture. So we have a prototype based on different technologies. So we have this in our supercomputing center. We use KVM as a virtualization, VLAN for networking. As a storage, we have SF storage. We use FreeHyper for the authentication, so we have some resources dedicated to this prototype environment. So for the cloud computing, so for the management of virtual resources, we use OpenNebula. So for, let's say, managing virtual machine and virtual networking. OpenNebula is, I don't know if most of you know OpenNebula. I think maybe you know OpenStack. But OpenNebula is a very nice product. It's pretty light, simple, as for easy to install, operate, and upgrade, also maintain. And it's an open source software for managing cloud and virtual machine and virtual networks and so on. And it also has an hybrid model for cloud bursting. So if you want to, for example, if your resources are overloaded, you can go on, I don't know, Amazon, Microsoft, or SoftLayer, and create and deal with machine also on that, on a public cloud. Regarding the container management platform, we use Ranger, and at the end, so we will have different components that are defined as Docker images and then as containers. And then we have implementing a Klima REST API engine that is that does some working in dealing with every layer in this architecture. So let me describe a bit about Ranger. Is a complete container management platform that you can run a container. This is also an open source with the enterprise support, so it's a production-ready environment. And the important thing that is can be integrated with many of the platform, cloud computing platform, as the concept of environment, multi-tenant environment. So each environment can be considered as an isolated environment where I can deploy resources, networks, volume storage, and so on. So the infrastructure is based on, so we have storage services, networking services, security, and also DNS load balancer. And it can be integrated with Kubernetes, Docker Swarm, and Mesos for example, for the scheduling and of container orchestration and scheduling. And then is this concept of application catalog. So what we have done together with the OpenNebula team, I wrote this OpenNebula Docker machine plugin. So if you want to integrate Ranger with any cloud computing platform, you just write a Docker machine plugin, and then you can look at this public request, where you can also integrate directly in the user interface of Ranger. So that's what we have done for this. So this is how it looks like a Ranger catalog. So for example, I can have different application. In our case are iRODS, for example, ICAT, a resource server, a REST API server. Then we have a couple related to MariaDB, Galera Cluster, and Postgres, and Solar and Threads. The MariaDB and the Postgres are from the community catalog. If you look at Ranger, there is a community catalog maintained on GitHub by community members, and the MariaDB cluster and Postgres are the same of that community catalog. So, for example, if I have, this is how it looks like the iRODS ICAT. So I can select a version. For example, I can have a service based on different release of iRODS, and then I have some configuration parameters. Okay, this is from the user interface. Clearly, Ranger has a REST API, so I can use the REST API in order to instantiate, for example, a service. So I can pass this. If you notice, you can link to other services like the Postgres database service. So if I instantiate first the Postgres database, then I can link it with that service. The reason is that Ranger has a lot of features that can help in deploy flexible and available. So just to give an idea, the Ranger environment will correspond to a Clima data service and the iRODS zone. So then we can use the external DNS, that is a service that in an automatic way can update the DNS when I instantiate a service that exposes a ports, so on the host. And this is useful because we need the fully qualified domain name for resource server and for ICAT. Then we use Ranger NFS as a storage service for persistent volumes, like for example for ADB, we need the persistent volumes. We cannot rely on the storage for the container. Also, Ranger has a load balancer we have used, and we have some tests on the load balancer for ICAT server. So it's also an health checking system, so you can recreate, for example, the container. If your VM is going to block, you can recreate the container on another resources. And then we use the Ranger metadata service in order to deploy an iRODS zone. So when I deploy the iRODS ICAT I decide what is the zone key. The zone key can be put on this metadata service. So if I instantiate then an iRODS resource server can look at the metadata service and then use the same zone key. And then we use the concept of sidekick services of Ranger. They are services that will be co-located with the real service, and then they usually initiate, for example, a volume, or can read the metadata and initiate some configuration files, so that the real service then can read and be instantiated. Okay. So just a few words about what we can do in the future. Okay, we will look forward for this scary arrow database plugin, what you said this morning, because instead of using Solar, we would like to have an internal metadata management in iRODS. We will look into the other kind of threads integration, and I don't know if it's possible to think about an HCDF library for iRODS, because that would solve a lot of problems. You have already implemented, for example, the SAM command, but maybe the solution in order to access directly in HCDF files from iRODS would be to implement an HCDF library, and then we can link any application with an HCDF library, but we have to keep the same API for the application side. So at CMCC, we have developed also a big data analytics platform that is especially useful for HCDF files, climate change scenarios, and we will try to integrate also this in the client as a service. And what we are looking also is automated scaling with the Ranger, because it has this Prometheus monitoring service and the webhooks that can also scale resources plus containers. And that's all. Okay.
Any questions? I've got to load one slides real quick. Anybody? Come and get it if you want a question. Thank you. Thank you.